Okay. Yeah, so the next thing we are going to look at is what we call latent heat. I'm sure that the earlier videos explained, a lot of things very clearly. And so right now we are going to be looking at latent heat and evaporation. So the question now is, what is latent heat? Now, based on our definition here, you can see that latent heat is the heat energy absorbed or released by a substance during a change of state. Now, that change of state is called phase change at a constant temperature and pressure. Now, what we mean is, though I'm still going to read this, but what we mean is that period where solid is changing to gas, or gas is changing to liquid, or vice versa, or liquid is changing to solid, whichever of them, those are phase changes. That means it's changing phase. If I put a block of ice on a table, after some time, you will notice that that ice begins to melt. Is that true?
Yes, that's true.
Yeah, so that means that the phase is changing. It is changing from a solid phase to a liquid phase. Are you getting me? So the heat involved in that is what we call latent heat. It's a special kind of heat. In this heat, there is no change in temperature. Now look at the first statement here, that during a phase change, temperature stays constant even as heat is added or removed. That means no change in temperature. You know, the one we saw earlier in our class, maybe the initial temperature was 30 degrees Celsius and the final temperature is 50 degrees Celsius. Now you can find change in temperature, which is change in temperature. Let me use theta, which is 50 minus 30, which is equal to 20 degrees Celsius. Okay, that's what we did before. But in this case now, in the case of latent heat, there is no temperature change. So we are not going to use the formula, the exact formula we used in the previous case. So, and this is an exam question. Whenever there is a change of phase, you will never experience a change of temperature. I state it again. Whenever there is a change of phase, you will never experience any change in temperature. Does that make sense?
Yes, sir.
Yes, sir.
Okay, good. Now, here it says hidden heat. The word latent means hidden. That means energy changes bonds, not temperature. You see, there are bond changes, but temperature does not change. There are intermolecular forces changes, but temperature does not change. Just like as you are now, there are some energy inside of you that whenever you want to do work, that energy helps you do the work. Do you understand? Okay, so we have two types of heat here. The first one is called latent heat of fusion, and the second one is called latent heat of vaporization. Now, the latent heat of fusion is the heat between solid and liquid. Are you following what I'm saying?
Yes,
It is
sir.
the heat between solid and liquid. That means as liquid is changing to solid or as solid is changing to liquid, the heat involved there is called the latent heat of fusion. Then between liquid and gas, liquid can vaporize to gas and gas can condense back to liquid. The kind of heat involved there is what we call latent heat of vaporization. So two types of heat. One of them is called latent heat of fusion, and the other one is called latent heat of vaporization. Am I making sense?
Yes, sir.
Okay. So that leads us to the next slide. Now, what is specific latent heat of fusion? Now, generally, let me say this. In sciences, whenever you see the word specific, it means per kg. It means per 1 kg. Okay, that's what it means. Like if I say specific temperature, it simply means the temperature in 1 kg. Okay, so by this definition, the specific latent heat of fusion, remember, latent heat is not the same thing as specific. Specific now, you are dealing with 1 kg, remember.
Okay.
In the same way we dealt with heat capacity and specific heat capacity. Heat capacity is the heat to raise the temperature through 1 Kelvin. But specific heat capacity now is to raise the temperature through 1 Kelvin, raise the 1 kg of temperature, 1 kg of a substance, to raise the temperature of 1 kg of a substance through, what is it called now? Through 1 Kelvin. So we look at the definition here. Specific latent heat of fusion is the quantity of heat energy required to change 1 kg of a solid. Are you seeing that 1 kg must be there in anything specific? So to change 1 kg of a solid to liquid or liquid to solid, anyone, at its melting point without any changes in temperature. This statement, please always note this statement. Without any changes in temperature, there will be no change in temperature as long as you are dealing with latent heat. So according to the formula now, Q is equal to ML. Now, I didn't write that well. Actually, that F is a small f. It should be written like this, MLF, small letter f. So the M there is what stands for mass. Then the LF there is what stands for latent heat specific, sorry. This should be specific latent heat. Specific latent heat of fusion. Okay, I think it's written here. Your Q is heat, your M is mass, and your LF is specific latent heat, which is J per kg. I hope I am making sense.
Yes, sir.
Okay. So I want to proceed. Can I move on? I'm going to still share my slide with you. Of course, it will be your property after now, so I will post it on the group. Is that okay?
Yes, sir. Thank you.
You're welcome. So I move to the next. So the other one is specific latent heat of vaporization. So the same definition. The specific latent heat of vaporization is the quantity of heat energy required to change 1 kg. You see that 1 kg again? Of a
Yes.
liquid to vapor or vapor to liquid. Vapor, another word for vapor is gas. So you don't mix it. At its boiling point. You see that? The other one is at its melting point. But this one at its boiling point without any change in temperature. Okay? And you can see that Q is equal to ML, the same formula, but now this one is LV. That LV means specific latent heat of vaporization. They didn't write it here, but you should know that. Okay? M remains mass. Now, I want you to see something. This is the value for water. Even though most times they will give it to you. In fact, anytime a question on this comes out, they will always give you the value for specific latent heat. But even if they don't, but they will always give you should know that the latent heat of vaporization is 2.26 times 10 raised to power 6. That's the formula for latent heat of vaporization. The previous one was, let me see it. You see, latent heat of fusion is 3.36 times 10 raised to power 5 joules per kg. This is for latent heat of fusion. And why this one here is for latent heat of vaporization. Are you with me?
Yes, sir.
Now, I want you to now note this point here for exam purposes. LV, latent heat of vaporization, specific latent heat of vaporization of water is about 6.7 times greater than the latent heat of fusion. What that means is that it takes far more energy to boil water than to melt ice. Hello, do you understand that?
Yes, sir.
It takes more energy to boil water than to melt ice. And that's the reason why specific latent heat of vaporization is much higher, is 6.7 times greater than the specific latent heat of fusion. Am I making sense here?
Yes, sir.
Okay, so I'm moving to the next one. So this one's now involve calculation. Now the first one, this one is on latent heat of fusion. The first one says calculate the heat needed to completely melt. Are you seeing? Now, this is how you will know that a question is latent heat. You will be hearing things like melt.
Okay.
Yes, when you see melt, when you see boil, I'm not boil, sorry, vaporize, then you know that that's what you are. Look at this one, freezes. Any statement that has to do with change of state. Look at this, melted. Are you seeing? Each of them have that statement, that particular word that signifies a change of state. Am I making sense?
Yes, sir.
Yes, sir.
Okay, so now you can see that we have calculate the heat needed to melt 2 kg of ice at 0 degrees Celsius. Okay, so in this case here, you don't need to bother about temperature because temperature is not involved in the calculation. What you need to do is Q is equal to ML. I already have the formula here, but that's okay. Q is equal to MLF. So your M, the mass is 2 kg, times the latent heat of vaporization of fusion is 3.36 times 10 raised to power 5. So all you need to do is to multiply 2 times 3.36. That will give us 6.72 times 10 raised to power 5 joules. So that's the formula for, that's the answer to that question. If you ask me, I think this makes a lot of sense.
Yes, sir.
Okay. So that now leads us to the next question. The next question says, please, if I'm too fast, you let me know. But I believe that because I'm still going to give you this, the note, you can easily follow through, right?
Yeah, it's okay
Yes,
like
sir.
this, sir.
You know, we don't have time, no time. I need to finish as much as in each class. Now, this one says, how much heat is released when 500 grams of water freezes at 0 degrees Celsius? Okay, now freezes already, that's latent heat. So 50 grams of water. First of all, you know that this mass, 500 grams, we need to change it to kilograms. And that's to divide by 1,000. If you divide 500 by 1,000, you're going to get 0.5 kg. So that means the heat now will be equal to 0.5 multiplied by 3.36 times 10 raised to 5. Okay, and that will give me, I think, about 1 point 1.68 times 10 raised to power 5 joules. Okay, we already have the answer. Okay, it didn't give us the final answer, but you have the answer there. Then this one is a little twisted. It says, what mass of ice can be melted by 1,008,000 joules of heat? Very simple. But in this question, if you notice, we are looking for mass. So we can still use Q is equal to ML, but this time around, it means that my mass is equal to Q over L because I'm looking for mass now. So
Okay.
I hope you understand.
Yes, sir.
Yeah, so my Q is 1,008,000 like this, divided by my L, latent heat is 3.36 times 10 raised to power 5. So if you divide this, you are going to get 3 kg. The answer is already here. 3 kg is the answer. Okay, let me give you a few seconds to digest that. Okay, so I hope I can continue. Hello, can I proceed?
Yes, sir.
Okay. I'm not getting responses from every other persons. Okay, so now look at this one. Latent heat of vaporization, right? Yeah, and I want to also say this, that I will also be uploading the recorded video on YouTube, but it's only you guys that can view it. So I will post the link so that in case you want to still go through the video, you can still go through it. You know, I need you guys to be 100% prepared.
That's good, sir.
Now, in this very case, we may not do all of the calculations, but at least I will just do one. It's still the same thing, the same ml. Like, have you noticed the word vaporize here?
Yes. I
You
saw
notice
it.
the word steam. These are terms to use. You see condenses. Those are terms of phase change. This one you see boiled off. Those are terms we use in phase changes. Okay, so this first one says calculate the heat needed to vaporize 3 kg of water at 100 degrees Celsius. So we are still asked to find heat. Your heat Q is equal to ml, but this time around your L is LV, heat of vaporization, talking about between liquid and gas. So your M here, your mass is 3, and your latent heat is 2.26 times 10 raised to power 6. So this will give us the answer. I think this is the answer they got here. That means 6.78 times 10 raised to power 6 joules, or you say 6,780,000 joules, and so on and so forth. Does it make sense?
Yes,
Yes,
sir.
sir. Yes.
Yeah, okay. My time is actually up, but there is still one part. But I actually have another class after now, so I may not go into this now. So there are two things. It's either I make a video this night and send to you guys, or we'll do it again tomorrow. But remember, we have to be fast. We have 30 days. It's a push. So meaning that it is you that will push yourself, but I would push myself to make everything you need available. Do you understand?
Yes, sir.
Yes. Okay. So I would, like I promised, I will make a video of the rest and post. So any questions so far before I call it a day?
Um, Let me see. Sir, please, I have a question. That of the specific latent heat of fusion, aside melting, is there any other word we can use to know, or is it just
Yes.
melting like
Melting,
in?
freezing, melting and freezing. You
Okay,
can also,
okay,
yes, melting
okay,
and freezing. Maybe ice melts or water
okay,
freezes. Then you
okay,
know it is that. Just like the other one, you hear things like either you see vaporize or boil off. Boil off means vaporize too. Then
okay,
condense. So those are
okay.
words to use to identify them.
Okay, sir.
Okay, so I think this makes sense. Give me a second. I need to quickly take a screenshot. Before you go, please. And please, I like to also say that you can actually invite friends to join in. I think I can make do with just 10 students. I don't want it to be much so that we can all follow. So 10 students are fine. We're almost there. So if you have them, you can just connect them to me and we can continue from there. Okay?
All right, sir.
Okay.
Okay, thank you. I can see some persons are missing here, but no problem. No problem. We'll continue tomorrow. So have a nice day, okay? Any other information, I'll post it on the group.
All right.
Thank you very much, sir.
You're welcome, my dear.
Thank you,
Bye-bye.
sir.
Good night.
Bye.
Yeah.